The next topic in this chapter is evaluating for normal distribution. And as I mentioned earlier, a lot of times we're going to be assuming that a data follows normal distribution or bell-shaped distribution. Now, when we make that assumption, we need to verify whether that is a reasonable assumption to make or not. So not all continuous distributions are normal. So it may have some skewness, or it may have some other properties that are not normal distribution, that are contrary to normal distribution. So it's important to evaluate how well a data set approximates a normal distribution. Oftentimes, this assumption is not very critical, like need not be exactly like a normal distribution, but it should be approximate enough. So a couple of things, there are a few things that we have discussed so far that we can check. First thing to do is to see whether it has no significant skewness. It is kind of symmetric. Okay? And remember, the bell-shaped curve, we had an empirical rule early on in chapter 3 that if you take plus or minus 1 standard deviation, about 68%. If you take plus or minus 2 standard deviation, you get 95%. And plus or minus 3 standard deviation, you get 99.7% of data. So we can check that and see whether that is true or not. Then we can look at interquartile range of a normal distribution will be 1.33 times the standard deviation. You can check that. 1.33 times the standard deviation. See whether that is approximately equal to the interquartile range. Another thing about normal distribution is mean, median, mode. They are all supposed to be the same. So we can check. We can compute the mean, median, and mode and see whether they are in the ballpark or if there is a huge difference. So, and we can construct charts. You can look at histogram and then see whether the histogram has a normal shape, or you can do a stem and leaf diagram. You can do a box plot. So there are lots of graphs that you can do. You can create and then see whether that is so or not. And of course, the descriptive summary statistics of mean, median, mode, and 1.33 times sigma for interquartile range, and plus or minus 6 sigma is the complete range for normal distribution. And this is the empirical rule. And there is another plot that we can prepare, which is called normal probability plot. And that normal probability plot is constructed using cumulative probabilities, and those lines should form a straight line. If it is very close to a positive straight line, then the normal probability assumption is reasonable. Otherwise, if it is not straight and if it is kind of curved, then it is questionable. So we will create all of this different aspects of verifying normality using Excel and StatCrunch, because for doing stem and leaf and box plot we have to use StatCrunch. Let's do all that for a problem.